Here we have our 24 volt DC source, a fuse, our DC input module, and our field input device. We're asked to connect the circuit, and we can use conventional flow theory to show it or electron flow theory. And we're going to choose conventional flow theory. And so we start at the positive side and come through to the fuse. And from the fuse this time, we're going to come down all the way to the common. And again, it'll go through the internal circuitry, come out of the input to the DC field device, and up through, and back to our negative, which of course is attached to ground. So if you look at this circuit, it comes through here. Once this DC field device closes, then it'll turn on the internal circuitry and everything will be fine. Now, if we were asked to figure out which is sourcing and sinking in this one, well, again, we follow the direction of current flow, just coming down here, and from the source. So in this case, this DC module will be sourcing, and the DC field input device will be sinking. Now that was opposite to the circuit we had before. Now over here, this wiring would be out in the field, and if it developed a ground on that wiring, let's look and see, let's analyze this and see what would happen. We'd come out of here, come across through the fuse, through the internal circuitry, and to ground. Now, this internal circuitry would always be high, and we would lose our control over here. It wouldn't matter if this was on or off. This circuitry would be high, so this could be on or off and it would not matter. Now, this could end up being a dangerous situation because we're losing control. And if we lost control, if this was operating, this switch was operating, turning on a saw blade or a solenoid or something like that, that was doing some type of action, it could end up injuring a person and or damaging equipment. So this type of circuit, even though it would work, in the event it developed a ground on the DC field input wiring, it could be a hazardous situation.